your notes. We're going to talk about standard F1 today. With standard, I can add, subtract, multiply, divide, and compose functions. And then to get the 4, I can utilize my knowledge of compositions of functions to solve real-life problems dealing with more than one function. I can also decompose a function and identify the functions that make it up. So today in the video, we're really just going to focus on standard, and then together, probably starting tomorrow, we'll start talking about 4 type situations. Okay, what's nice about this standard is that you already know how to do all of it except one piece, composing. The first example is just a review of what you already know how to do. Add, subtract, multiply, and divide. A few different functions we've used already in this class. The rest of the standard will focus on composition and what that looks for algebraic functions. So, for example, when I want you to make an A, B, and a C. I'm going to give you 2 functions for each one. Okay, my f of x function is going to be x squared plus 3x. My g of x function is going to be x cubed minus 3x squared plus 1. And then we're going to do 2 things here. We're going to find f of x, well, we'll just do one thing. How about f of x times g of x? Okay, so you have 2 different functions, and the operation, well, actually it's probably going to be labeled this. The directions would say something like, find h of excuse me, find h of x if h of x is f of x times g of x. So you have to look at what f of x and g of x are and actually set it up that way. So h of x is f of x times g of x. Well, since both these are polynomials, like this is a quadratic and this is a cubic, we've already kind of done this when we were multiplying polynomials together. So let's go ahead and do that. Simplify. We get x to the 5th minus 3x to the 4th plus x squared. And then when I distribute 3x through, I get 3x to the 4th minus 9x cubed plus 3x. So h of x here is going to be x to the 5th. Those completely cancel out. Minus 9x cubed plus x squared plus 3x. Okay, so combination of functions is a fancy way to say add, subtract, multiply, or divide. Let's look at 2 different functions for b. 3x to the 2/3 for f of x, and g of x is going to be for x to the 4/5. Okay, so I know we talked about yesterday the fact that x to the 2/3 really means the cube root of x squared, because this is power and that's index. So this would be the 5th root of x to the 4th, because the 5 is the index. But instead of converting them to radical form, we're going to leave them as is, because the thing I'm going to do, or the combination I'm going to ask you to do, is f of x divided by g of x, which would look like this. 3x to the 2/3 divided by 4x to the 4/5. Now, we've dealt with exponential functions before, or excuse me, properties of exponents before. So if you were to look at this as 2 pieces here, we have 3/4. If you can't reduce that any more than it is, then just leave it 3/4. But then when you are dividing 2 things to the same base, you can simplify that by subtracting the exponents. Now, out of these 2 exponents, the 4/5 is more, so I'm going to take the 2/3 and subtract it from 4/5. And let's go ahead and do that over here. I need common denominators, so this would be 12/15. This would be 10/15, which would give me 2/15. And since you're taking the 4/5 and subtracting to the 2/3, the 2/15 would be in the denominator, and you can leave it like that. Okay. Let's look at one other type of function here. Go 3x to the 4th plus 2x to the 1/2. And then we'll go 4x to the 1/2. That's your g of x. And my h of x here, I'm going to make a new function by adding my two functions. So you take your f of x, and we're going to add g of x, and then simplify. Now in this case, like I know this power of 1/2 means radical here, means the square root. But since I'm just adding, I'm just going to add my like terms, which then these are my like terms. And I would get h of x equals 3x to the 4th. And then if I add my like terms together, I get 6x to the 1/2. Or you could write it as 3x to the 4th plus 6 times the square root of x. Either one. Okay, so the first part of this standard is you can add, subtract, multiply, and divide functions. Very similar to a, b, and c here. So let's discuss something you already know. When I ask you to find f of 3, so if I gave you a function, and sorry, we're stopping this and then we're going to talk about composing next. When I ask you to find f of 3, what am I asking you to do? I'm asking you to plug 3 into f of x, whatever function that is, for x, to find y. Thankfully, since like we already know how to do that, composition of functions just does that. The twist is that instead of a number being substituted into the function, like instead of saying f of 3, a function is substituted into the function. So instead of saying f of 3, I might say f of g of x. So instead of the 3, you have a function that you're plugging in. So essentially, you're going to have a function inside another function. Okay, so composition of function. Okay. So in this case, h of x is going to be f of g of x. You can also write it as g of f of x, like you can flip-flop what you're plugging into each other. The other way, you will see it sometimes written notation-wise. Looks like this. So if you see what we call the fog problem, because it kind of looks like it's spelling the word fog, that doesn't mean multiplying. It just means composing. So it's the same thing as this. It's just we're used to function notation like this, so that's what I'm going to stick with. Alright, let's go ahead and label two functions here. X squared plus 3. G of x is going to be 2x plus 1. Okay, we're going to do two compositions here and simplify. The first one, we're going to do f of g of x. Second one, whoops, we're going to do g of x. Now keep in mind the f and the g just refer to what function you have up here. So to create this new function, what this is telling me to do is to take the whole entire function of g of x and plug it in for x in the other function. So like if I said find f of 3, you'd plug 3 in for x. Well, I'm saying f of g of x, you're plugging g of x, that whole thing, in for x. Okay, so let's see what that looks like. Instead of x, and a lot of times what I'll do when I'm composing functions, if I'm not sure quite how to write it, I'll rewrite the function I know I'm supposed to be plugging into, so the one on the outside. And instead of writing anything in, I'm just going to leave parentheses where the x does go, because I know I'm going to have to plug something in for that. And then I know in this case I have to plug in 2x plus 1. Now to simplify, 2x plus 1 squared means 2x plus 1 times 2x plus 1. So we're going to FOIL that out. First terms give me 4x squared. Outer and inner give me 4x. 1 times 1 gives me 1. So I get h of x equals 4x squared plus 4x plus 4. Okay? But again, we got to this new function by plugging in g of x for x in the original. Let's do another one here. Now g of x, that's saying you're plugging this whole function into itself. So again, I'm going to write the function, and instead of writing the x, I'm going to leave a parentheses. So notice it looks exactly the same as this, except my x, I know I have to plug something in for. And then what I have to plug in for x is the entire g of x. So 2x plus 1. And let's go ahead and simplify. You can distribute the 2 through, then add your like terms. And you're done. Okay. It's been about 11 minutes or so. We have, I think, time to do this example here. Okay, so you'll need to be able to do this with polynomials like quadratics and linears, but then you'll also have to do it with functions that look like this. We'll go 2/3 on that one, and 5x to the 1/2. Okay, so I know technically these are radicals. This is the square root of x. This is the cube root of x squared. But instead of converting to radicals in this case, I'm going to leave them as is because they are going to be easier to deal with. Okay, let's do g of f of x as my first composition. Then we'll do f of x. Okay, so this is telling me I want a new function. That new function is going to be created by plugging this into g of x. So I'm going to start by rewriting g of x with everything there except for the x. And then to replace the x, I'm going to put that entire function of f of x. And then we're going to simplify. Okay, I have 5. Now, this 1/2, because it's outside the parentheses there, I have to distribute to each term. So we're going to have 5 times 4 to the 1/2. And when you multiply, when you have a power and a power like this, you end up multiplying them together. So 2/3 times 1/2 ends up getting you 1/3. And then we're going to go ahead and simplify as much as possible. Keep in mind that when you have a power of 1/2, what that really means is that it's the square root, because you have a power of 1, and the 2 is your index number. So square root of 4, let's actually convert that one. If you want, you can convert this one too. But notice we didn't convert right away because it is easier to deal with properties of exponents than properties of radicals. Oops. Okay. Square root of 4 is 2. 2 times 5 is 10. And then we have the cube root of x. That would be as simplified as you can go there. And then for part B, we're going to do a very similar problem here where we take f of x and plug it into itself. So I'm going to rewrite f of x. Again, with a blank spot here that I know I have to plug in, so it looks exactly the same as f of x did. I just left a blank where the x was. And then we're going to plug in 4x to the 2/3 and simplify. Again, you have to distribute the 2/3 through, so you get 4 times 4 to the 2/3. Power and a power you multiply, so you get x to the 4/9. And there's not much simplification we can do here because you get 4 times the cube root of 4 squared, that's what this 2/3 ends up being, times the 9th root of x to the 4th. Yeah. So we have 4 times the cube root of 16. 16 doesn't have a cube root, so we have to leave it as is, is 9th root of x to the 4th. And that's a simplified, I know it looks ugly, but that's a simplified as you're going to get. And let's label those both h of x. Okay? So to get a 3 on the standard, you're going to have to be able to do compositions. So look like this. I know we spent 2 examples talking about compositions and just 1 talking about adding, subtracting, multiplying, dividing, because that one we've practiced before, but this one we haven't seen, so I wanted to spend more time on that. Alright, so we're done with the video for today. Tomorrow, we're going to work more on S2, plus look at these 2 examples on how to work with composition. Like these are 4 type problems, and actually if you want to go ahead and label those, that way we remember to do that tomorrow. Alright, you're done.